Alright, this is the notes on simplifying radicals. Radicals is another word for square roots. So instead of what we've done before with square roots is if you had the square root of 5, you might have just typed in the square root of 5 into your calculator, hit equals, and it comes out with some number. Or the square root of 18 or 20, or you take a square root. It's real easy to just put it in the calculator and get a decimal, but what happens when you take the square root of a number is the calculator actually rounds the number. It rounds the number for you, so it's not exact. So when we want exact answers, we need to keep the square root in the square root form. And that's why we simplify radicals, which is what we're going to learn today. So the top here is just a couple things to always keep in mind whenever you are simplifying radicals. It says an expression with radicals is the simplest form if the following are true. Now, we should have no perfect squares, square factors other than 1 in the radical. Now, speaking of perfect squares, you should already have a list of perfect squares. Okay, I'm going to just pause the video real quick and write down the perfect squares so we don't waste any time. Okay, so I've posted the perfect squares there on the left hand side. These numbers that are in the square roots are considered perfect squares. The reason why they are considered perfect squares is because they come out to perfect numbers. If you were to take the square root of each of these, it would come out to a nice whole number. Anything else is going to come out to a decimal. Now, it does go higher than 225. It goes to an infinite amount of numbers. But we only need to go to 225, or the square root of 225, which is 15. So that's as far as we're going to go. It's important to have this list of perfect squares because how you simplify radicals is into perfect squares. And I'll show you how we're going to do that. So now, you should not have any of these in your answer. You should never have a perfect square in your answer. If you do have a perfect square, take the square root of it. Okay, there should be no fractions in the radical. Okay, you shouldn't have any fractions inside. If there are, we'll talk about how to deal with that actually in a few days here. And then the third one, no radicals appear in the denominator of a fraction. So there shouldn't be any radicals in the bottom of a fraction as well. So radicals and fractions kind of we just don't really like. So we'll show you in a few days how to take care of these last two. But today we're going to work on this first one here. Okay, taking out perfect squares within a radical. So here is a example of the square root of 50. Now, there's a process to this, okay, which is called, and they call it prime factorization. So an upside down, or it's a prime factorization tree. So we're going to make a tree and split this 50 like this. Now, what you split the 50 into, you need to find a perfect square that goes into 50. And that's where your perfect square list over here comes in. We need to find one of these numbers that's going to go into 50 evenly. Now, there's a trick. Okay? You don't just need to start, seeing, okay, does this go into it, 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 does this go into it. No, you don't need to do that. Okay? There's a trick. What you're going to do is take the number that is inside the radical, and you're going to cut it in half. If I cut 50 in half, that's 25. Well, if I look on my list, I see that 25 is already a perfect square. Now, if it wasn't a perfect square, that would be my starting point, and I'd work from there. The goal is to find the highest number, the highest of these perfect squares that goes into 50. Now, once we cut it in half, we get 25, which is already a perfect square. So we write this as the square root of 25. And then how many times does 25 go into 50? 2. Okay. Now we split it up so that we have a perfect square. The reason we do that is because now we know what the square root of 25 is. We know that the square root of 25 is 5. And then all we need to do is attach the other radical. And that is square root of 50 simplified. Okay? So let's try another one. Again, this is a process. It's going to take some practice. Okay, 72. 72 is going to break down. Now, remember we cut it in half. If we cut 72 in half, you get 36. So we go over here to our perfect squares list and look for, well look, 36 is already a perfect square. Well, that's perfect. So I know that it's going to go into 72. 36 will go into 72. Always write your perfect square first. Now, how many times does it go into 72? Well, it goes into it twice. So the other radical is 2. Now, we know the square root of 36. The square root of 36 is 6. And then we just attach the other radical. Now, though these may seem simple, they do get more difficult as we move along. So, now, square root of 98. Okay, this is another one where we split it. Okay, we split it in half, and come to find that half of 98 is 49, and 49 is already a perfect square. So we go over here. Square root of 49. It's important that you put the square roots there. Don't just put 49. It has to be the square root of 49. And 49 goes into it 2 times. We know the square root of 49. That's 7. And then you just attach your other radical. Now it's not always going to work out that easy, as you're going to see here in this next problem. So what happens though if we have a number out front? We have a 5 in front of the radical. Well, it turns out that the 5 doesn't really make any difference until the very end. So our goal is still going to be to simplify this radical, and then we'll take care of the 5 at the end. So we're going to take care of this radical. Now when we cut 80 in half, you're going to notice half of 80 is 40. So when we go to our perfect square list, okay, wait a minute, Mr. G, 40 is not on here. 40 is just a starting point. If it happens to be a perfect square, then that's great. But oftentimes, it will not be a perfect square. So 40 is our starting point. So we're going to look here. 40 would be right in here. This is where 40 would be if it were here. This is our starting point. So now we're going to work our way up. From the bottom, we're going to work our way up, seeing what is the highest number that goes into 80. Okay, we start at 36. Does 36 go into 80? If you answered no, then that's correct. 36 does not go into 80 evenly. So then we move up. 25. Does 25 go into 80? If you answered no, then you're correct. 25 will not go into 80 evenly. And remember, keep in mind we're using these numbers, not these numbers. These are the answers. These are the numbers that need to go into it. These are our perfect squares. So the next number up is 16. Does 16 go into 80? If you answered yes, then you're correct. 16 does go into 80. So when we go over here, the number that goes into 80 was 16. How many times does 16 go into 80? It turns out that it goes into 85 times. Okay. Now, we know the square root of 16. The square root of 16 is 4. And then we attach the other radical. But remember that 5? Remember that 5 up here? Here's where it comes into play. That 5 now needs to be multiplied to this number in front. Okay, 5 times 4 is 20, and then radical 5. And that is that radical simplified. Okay, think you could try one on your own? Why don't you go ahead and do number 4 on your own. Pause the video. When you're done, hit play to check your answer. Okay, so you should have gone through 112, cut it in half. If you cut 112 in half, that's 56. 56 then becomes your starting point. As you work your way up the perfect squares list, The first perfect square that goes into 112 is 16. Okay, 16 right here goes into 112 7 times. That's why we have square root of 16 and square root of 7. Now we know the square root of 16, that's 4. Then we attach our square root of 7. But this number that's out front here then needs to be multiplied. Negative 6 times 4 is negative 24 radical 7. Okay. Same thing goes with fractions. You could even multiply fractions here. If we split 32 in half, 32 in half turns out to be 16, which is a perfect square, so that works out. 16 goes into 32 2 times. Now we know the square root of 16, it's 4. To attach the radical 2, and even though there's a fraction out front, we still can multiply. Use a calculator, or if you don't have a calculator, just what's half of 4? Or multiply times the top and divide by the bottom. Okay? 4 times 1 is 4, then divided by 2 is 2. So now we have 2 radical 2. Why don't you go and try 6 now on your own. Pause the video, try out the problem, hit play to find the answer. So I've done the factoring here for you. Now 45, the highest perfect square that goes into 45 was 9. 9 went into 45 5 times. Now we know the square root of 9, that's 3. Attach the radical, so we have 3 radical 5. The last step now is to multiply this fraction here in front. Now 3/5 times 3 might be a little difficult, but remember that you just multiply times top, divide by the bottom. So 3 times 3 is 9 divided by 5. It doesn't go into it evenly, so you just leave it as 9 over 5 radical 5. That's simplifying radicals. Okay. The last thing here is what to do when we have letters or variables inside of our radical. Now, the nice thing that when we have multiple things inside the radical is we can actually treat them as completely separate radicals. So, for example, you have the square root of 25. This is square root of 25, a to the 8th, b to the 15th. We can separate them into 3 separate radicals. Now it becomes a little easier. Square root of 25, well, that's easy. That's 5. But what do we do with the variables? Okay. With exponents, you cut the exponent in half. So the answer to the square root of a to the 8th is half of that exponent, which is a to the 4th. Now what if you say, well, Mr. G, b to the 15th, that 15 doesn't cut in half, it's a decimal. Do we just write 7.5? And the answer is no. Okay, you want to see how many times that 2 goes into the number evenly. For a to the 8th, 2 goes into 8 4 times evenly. But 2 goes into 15, it only goes into it 7 times evenly. So when you write this, you write b to the 7th. Now the problem is that you think of when you were doing long division. If it didn't go into it evenly, you had a remainder, right? Well, 2 goes into 15 7 times. There's a remainder, though. There's an extra b. And so that extra b we leave actually in the radical. That extra b to the 1. Okay? You should see this when you do, 2 times 7 is 14 plus the 1 remainder. Okay? 2 times 4 is 8. Okay? And that's how you do these variables. So we're going to get a lot of practice with this tomorrow or in cycle 10. So if this is still a little confusing to you, don't worry, we're going to hit a lot of practice with this. But basically, cut the number in half. If it doesn't cut in half, you see how many times 2 does go into the number, and then write the remainder still inside the radical. Okay? Let's try some of these problems. Now, we've made them all even numbers to make it easy, just so you kind of get how to do it. So, with the square root of 4x squared y to the 8th, remember, do each part separately. I know the square root of 4. The square root of 4 is 2. And then all we do is cut our exponents in half. X to the 1 and y to the 4th. That's it. Here, square root of 100 is 10. Cut the exponents in half. A, 3, B, 2. Square root of 81 is 9. Cut the exponents in half. X1, Y1, Z6. Okay. What about adding and subtracting radicals? Okay. This is called radical arithmetic. Okay. So now instead of working with just one radical, we're going to be working with radical arithmetic. Radical arithmetic, and if you're looking to fill this in the box, is adding, you can put add or subtract radicals. Okay, radical arithmetic is whenever you're adding and subtracting radicals. Now, what's nice about adding and subtracting radicals is they work the same way as like terms do, like x's and y's. And when to have, like for example, if I were to do 3x plus 5x, well, that's easy. 3 plus 5 is 8x. Radicals work the same way in that they have to be like terms. So here you have 2 radical 5 and 4 radical 5. This you can add. Because they have the same radical, you can add them. And you add them just like they were x's. So 2 radical 5 plus 4 radical 5 would be 6 radical 5. Okay? You can combine them because they are like terms. They have the same radical. They have to have the same radical in order to combine them. So if you look at this one, 2 radical 8 and 4 radical 7 have completely separate radicals. And if this happens, you can't combine them. And this, therefore, is simplified. Okay? So let's look at some examples. We'll leave these pretty easy to start here. 4 radical 13 minus 6 radical 13. 4 minus 6, negative 2 radical 13. Go ahead and try 2 through 4 on your own. Pause the video and hit play when you're ready to check your answers. Okay, so you can see here, number 2, 1, okay, 1 radical 17 and 9 radical 17 makes 10 radical 17. 2 minus 5 is negative 3 radical 3. Negative 2 minus 4 is negative 6 radical 5. Just be careful. You need to make sure that they have the same radical in order to combine them. All of these did, so it works out. Now, what happens when they are not the same? Now, before you write it off and before you say, well, can't do number 5, they're not the same, I can't combine those, they're not like terms. Before you go ahead and write it off, you need to check and make sure that your radicals can't be simplified any further. If you look at number 5, let's look at number 5 closely. You'll find that though the radicals don't match, 48 actually can be broken down and simplified. Okay, 48, if you go back to your perfect squares list, the highest perfect square that goes into 48 is 16. So radical 16, 16 goes into 48 3 times. We know the radical 16 is 4. Attach the radical 3, and don't forget that this 4 in front will need to be multiplied. 4 times 4 is 16 radical 3. And now we have this part up here, minus 6 radical 3. Now you'll notice that because we simplified radical 48, that these two radicals now have the same square root. And we can now simplify this. 16 radical 3 minus 6 radical 3 is 10 radical 3. Okay, so like I said, be careful when you're doing this. Don't write it off too early. See if you can simplify a radical before to see if you can get like terms. Number 6. Can you combine them? Not as they are right now, you can't combine them because they have completely separate radicals. But could you maybe simplify 98? Go ahead and try and simplify square root of 98. Pause the video and check your answers when you're done. Okay, so we simplified radical 98, cut it in half. That was 49, and we noticed that 49 is a perfect square. So square root of 49 goes into it 2 times. Square root of 49 is 7. Attach the radical. Don't forget to multiply this 3 here. So 3 times 7 is 21, radical 2. And now you'll notice that this up here plus 6 radical 2, they are now the same radical, and therefore we can combine them now. 21 and 6 is 27 radical 2. Okay. Now sometimes we're going to skip 7 and go to 8. Sometimes you may need to simplify both of them to get a common or like term. So don't write it off right away until both radicals are completely simplified. Okay, so 48, the highest perfect square that goes into 48 is 16. 16 goes into 48 3 times. Square root of 16 is 4. Attach our radical 3. And don't forget to multiply by the 8. 8 times 4 is 32. Radical 3. Now, the second radical, I'm going to show you here in a different color, can also be simplified. The highest perfect square that goes into 27 is 9. Okay, 9 goes into 27 3 times. We know the square root of 9, that's 3. Attach our radical. And don't forget to multiply the number in the beginning. 3 times 3 is 9, radical 3, positive 9. And now you'll see that we have 2 radicals that are like terms, and now we can combine these. 32 and 9 makes 41 radical 3. Okay, and that's simplifying radicals. Okay, that's all we got for you. If you have any questions, always just message me on Canvas. Well, we're going to get a lot of practice here in Cycle 10 dealing with radicals. So, hope this helps. And then, like I said, if you have any questions, message me on Canvas. All you had to do was finish the video notes, and that was your homework.